Alex, Assistant Professor from St. Xavier's Catholic College of Engineering, Nagarkoil. This session, I am going to discuss about deep learning for star galaxy classification. This session, we are going to see introduction to star galaxy classification and some of the research works on star galaxy classification using deep learning models. Galaxy is a system of millions or billions of stars together with gas and dust particles held together by gravitational attraction. Human-made technology can observe and detect 100 billion and 200 billion galaxies. Based on shape, the galaxy is categorized into elliptical, spiral, and irregular galaxies. The classification of stars and galaxies from astronomical images is a tedious task, but it is an essential process for researchers in the field of astronomy. In manual classification, the outcome is highly dependent on the researcher who analyzes the data. Similarly, the volume of data is more. Machine learning learns features directly from the data that makes automated star galaxy classification faster than the manual classification. Traditional star galaxy classifiers are based on the reduced summaries, which is provided by the star galaxy catalogs. These classifiers need careful feature selection, and domain experts are needed at various stages of classification. The traditional methods are not scalable. This paper proposed a scalable probabilistic classifier based on source information with minimum involvement of experts. This work uses convolutional neural network that performs binary star galaxy classification from photometric catalogs. Another work used deep convolutional neural network that classifies stars and galaxies in SDSS data and CFHT lens photometric images. This model trained on spectroscopic sample, hence the performance of deep convolutional network is less reliable. By combining this model with unsupervised methods, that is meta-classification framework, will improve the star galaxy classification performance. Deep learning has promoted rapid progress in computer vision with regards to object identification and object detection. This motivates the authors to apply deep learning methods to star galaxy classification, but these methods cannot be applied effectively without some modifications. Here, the classification of one object cannot be determined without knowing the context of the surrounding objects. This is called context classification. This involves three steps: local modeling, global modeling, and prediction. Each step is based on own neural network. The local modeling, it extracts the local features. Global modeling extracts the global features. And the prediction step takes these local features and global features to produce a class prediction. This classification framework classifies the non-IID data. Next work is CAS-VAE. This work is focused on solving the challenge of increasing the amount of data. So this model is a cascade variational autoencoder. It's an unsupervised approach for star galaxy classification task. This model learns the pixel values of photometric images, and its classification performance also improved when compared to baseline methods. So some of the outlooks about this star galaxy classification needs to develop scalable classification frameworks and to develop efficient meta classification framework that will improve the efficacy of star galaxy classification performance for photometric survey data. With this, I